You have probably seen hundreds of tutorials saying train this model, import this library, get 95% accuracy. But have you ever stopped and asked yourself, why are we doing each step? Why do we fill missing values? Why do we scale features before training? Why do we even split data when it is already there? You see, these tricky steps decide whether your model performs like ChatGPT or like a random guess. And that is where most beginners fail. In the real world, companies don't hire people who can just run SQL code. They hire data scientists who understand the why behind every line they write, because only they can explain the logic behind their model to clients, managers, and the business team. So, in today's video, I will show you the exact process a real data scientist follows when building a model using a completely raw, imperfect data set that looks nothing like what you see in Kaggle tutorials. Stick around till the end, because if you understand this one machine learning pipeline, you will understand how real machine learning actually works and why the best engineers are obsessed with the data, not just models. Let us jump to my screen and I will show you what real machine learning project looks like.
All right, let us start. So here's our data set uh, in my coding screen in my VS Code. This is my data set, which is the churning customer churn data set. And so these are the customer IDs. These are the features of a customer, and this is churning result. Zero means the employee is not leaving, or it is not, or the employee is not churning, and one means employee is leaving. Okay. Now, so we have imported this data set using pandas. So first, I will import the libraries pandas and numpy. Okay, these libraries are used basically for data cleaning and data analysis. After that, I will import the data set from my Excel file. Okay, using PD, and I have named it as DF. Okay, so it is your pandas data frame now. Okay, so imported the Excel file into pandas data frame called DF. Right now, before the analysis, first we should understand the problem. That what is the business problem. So here we are going to predict the churning of a particular employee. So we will use this data set to train a machine learning algorithm, and then it will predict. Okay. Now the next step, step 3, is data exploration. So here basically we will talk about, or we will basically see that how the data looks like, the overall description of the data, the statistical description of the data. So that will be done using df.info. Okay, info code is used to get the description of the data, and then is null.sum, that is used to check the number of missing data in the data set. Like here in the monthly charges column, I have NAN not available, that is missing data, and in the tenure we have NaN again here. Okay, since this is a very small dummy data, so we can easily count the number of missing data, but in the real data set, which will have thousands of rows, you have to use this code to get the total number of missing data. So when you so once you execute it, let me execute this also first. Okay, so yeah, now if I execute this, so I will have the types of columns, types of data in these columns, and next for every column the number of missing data. I am getting one here, that is for monthly charges, which is obvious. Here I have null data, and for one for tenure, one means I have NN here as well. Okay, for other columns it is zero. There is no missing data in other columns. So now since we have the missing data, we need to fill them. So we will fill these columns missing data, fill NA. Okay, using the median in the monthly charges means I will fill this NAN with the median of all remaining known values. Okay, and for the tenure, I will fill this NA value in the tenure with the mean of remaining known values. So I will fill this NAN with the mean of the remaining known values. Why? Why mean and median in these cases? So in monthly charges, we can see that we have some outliers like 5,000, which are very high as compared to other data. So we will use here we will use the median, because mean is affected by outlier significantly. But in tenure, all datas or all tenures are more or less close to each other, so we can easily use the mean here. There is no outlier. Now after this, handling imbalance, step 5, handling imbalance data. So here we can see that in the churning we have 5 zeros and only 3 ones. Since it is dummy small data, so right now the difference is not that much, but suppose if you have 10,000 rows and out of 10,000 you have only 200 zeros and 9,800 ones, that is called imbalanced data set. Okay, and if you use if you train your model on such data set, then the model will predict only a particular type of category, which is majority category. Suppose here the zero is the majority, so if you train it on this data set, then it will predict only zero for any employee. So that's why we need to basically make it balanced. For that, we will do random oversampler. We will use this random oversampler library. What will it do? It will basically oversample the minority categories. Means it will add the rows of minority categories randomly. Okay, so that's what we are doing here. So once I do that, after that, you can see that if I check the DF here, again, after doing the random oversampling, I will have 10 rows now. Earlier, I had only 8 rows. Now I have 10 rows and you can see 5 zeros and 5 ones. So it is balanced. Okay. After that, I will do encoding in the categorical data. So what does it mean? In this, basically, the model cannot read the text like male, female, Delhi, Mumbai, like, yes, no, like this, right? So it needs numbers. So we will convert all these categorical columns like gender, city is active using one hot encoding. So one hot encoding using get dummies. Once I do that, my data set looks like this. Okay, gender 10. So male, female, I have encoded like this 10. Cities, there are two cities, Mumbai, Pune, and there is one more city. I think three cities are there: Mumbai, Pune, Delhi. So it has got columns for Mumbai and Pune. For Delhi it is understood, right? If it is false for Mumbai, Pune, 2 will be for Delhi. So like this, false, these are numbers only, right? False is like 0, 2 is 1 for the computer. Okay, after that we need to scale the data set. So here is something which most beginners overlook. Our monthly charges are in hundreds, except these two 5,000, mostly they are in hundreds. Okay, and but total spend is in thousands. Okay, so if we skip scaling, the model will treat total spend as more important, not because it actually is, but because the numbers are bigger. So we need to have same scaling for all columns. Okay, so that's what we are doing it here. Okay, so let me first execute all these things so that you can easily see the results of these operations. Okay, so if I just do this handling imbalance thing, so I got this, then and okay, before that, let me also do this thing, mean filling NA values. Now we can see. So see, NA values are also filled now. There is no NA value, right? Then encoding thing, we have got the encoded thing here. Okay. Now feature scaling, here we will use standard scaler. Standard scaler is the library which makes all data to a range from -1 to 1. Okay, so all data will get converted to -1 to 1. Okay, so we will import this standard scalar library from scikit-learn.preprocessing, and we will make another data set from df that is called scaled df. So that is the data set after scaling. Okay, so once I do that, let me check. Okay, so once I do that, see, I get all numbers from -1 to 1, and if I just want to see the full scale df, see, you can see all 10 rows are here. Okay, now after this we will do the train test split. So in the real world, a model is judged by how well it performs on unseen data. So we will split the data set. The general uh, basically the general factor to divide a data set into train and test is 0.25 and 0.75 or zero point 0.2 and zero point 0.8. So here we are dividing it. So this is my x scale df. So that is only input variable, and y is the churn from the df. So that is my output variable. So I will divide the data set into train and test. Okay, x10, x test, y10, y test. And test size is 0.25, means 25% of the data will go to the test data. And random state 42 means that if you keep it same, okay, for all runs, okay, so then you will get the same train and test data. Okay, so that's why we do it. Now, after this, the train test split is done. We got the shapes of train and test data. Then we will do the model training. Yeah, since it is classification problem, right? We are categorizing any employee as churn or non-churn means 0 or 1. So we will use the simplest model, that is logistic regression. So we will import it from sklearn.linear model, and then we will fit it on xtrain and ytrain, and then once we execute it, the model training is complete. Then we will evaluate the model, that is using metrics. Okay, we will import the confusion matrix and classification report. These are the two basic two ways to represent any accuracy, or to present basically any metric of a machine learning model. So once I do that, so model dot predict for X test. So we are predicting now the output for input. Input means X test. Okay, so that is the input of test data. So we will predict the Y variable or the Y value for X test data. Okay, the X input variables in test data. Once I do that, model dot predict, I got the output, that is confusion matrix. Confusion matrix will show you the number of yes and no. Okay, against the uh, basically the accurate results. Okay, so this will show you the metrics, and this is your classification report, which shows the different matrices. Okay, like precision, recall, F1 score, like this. So it is one for all, because my data set is very small. Okay, it is dummy. So it is basically almost memorizing the whole data set and giving you 100% accuracy. But this is not true in real cases, right? Since your data will be very huge. Okay. After this, you will just save the model, which you can use for user interface, and you can use that to predict the values in your user interface. So you will generally save your machine learning model weights in the pkl format file. So once you save it like this, okay, so your file will get saved here. You can see churn model.pkl. Okay, so once you save it, it will get saved in the folder. So this is how it works.
So that is the real machine learning process, not just model training, but understanding, cleaning, balancing, encoding, scaling, and evaluating data like a professional. If you have watched till here, you now know what most people skip, the why behind every step, and that is what makes you valuable in the AI industry. If you found this video helpful, subscribe and hit the like button on concepts of AI, and be ready with such videos in the future as well.